Today we are looking at Rhino3DPRINT, which provides automatic and high-performance mesh processing inside of Rhinoceros 5. In a few moments, Kyle Hutchins and Uday Hunalagre will be showing you how to use the latest MecSoft product for 3D printing called Rhino3DPRINT. Kyle is owner of the Outside Digital Design. He is a product designer and a McNeil technician. Uday Hunalagre is a technical support manager at MecSoft and a computer scientist. Also helping out Kyle and Uday are Anita and Joe Anand from MecSoft, Scott Davidson, and myself, Mary Puchet, from Robert McNeil & Associates in Seattle. We will be responding to the chat questions, so feel free to ask them at any time. We will also review any chatted questions so that they can be answered verbally for the video. Today's schedule: the presentation will take about an hour, and we will have time for questions at the end. First, I will cover the basic features of Rhino3DPRINT. Then Kyle will show us a model that he has, in his words, thrown together, and he needs it to be 3D printed now. Uday will take Kyle's model and process it with Rhino3DPRINT's tools to produce a good mesh for successful 3D printing. After, Anita will talk about pricing, support, and training. Then we will open it up for questions. So that's a lot of fun, so don't be shy. Hopefully some of you will put your hand up so that you can ask your questions live and directly to the presenters. We all have a lot to share with you, so please be patient as we pass the mic during transition times. MecSoft is a California-based company and is known for making software products for the subtractive manufacturing or CNC industry. You may either use or have at least heard of RhinoCam. That is the Rhino plugin used to generate milling, turning, and drilling tool paths on the Rhino model. With the product that you are about to see, Rhino3DPRINT, MecSoft is expanding into the additive manufacturing or the 3D printing market. I want to cover the basic features of Rhino3DPRINT briefly with a couple slides. These are the features that you will also be hearing Uday talk about in more detail during his presentation. To start out, let's define Rhino3DPRINT as a Rhino plugin that simply prepares 3D data for 3D printing. The key: these meshes may be troublesome and otherwise not be able to be 3D printed, or they may take an exceptional number of hours to fix with just Rhino. Rhino3DPRINT repairs the mesh in Rhino, exports STL or to the AMF additive manufacturing file format, as well as the 3D printers in Windows 8.1. Let's look at the process. Import data in any major 3D format, or create 3D content using Rhino's powerful NURBS tools. Prepare data for printing using Rhino3DPRINT, and send to a 3D printer or export to STL. Okay, so that's just a brief overview of the process. Rhino3DPRINT also automates turning point cloud data into closed meshes that are ready for 3D printing. Rhino3DPRINT performs mesh booleans, union, subtraction, and intersection, that may be too complex for Rhino's built-in mesh boolean commands. Rhino3DPRINT auto-fixes meshes to remove gaps, holes, and self-intersections. It is not unusual to have 20,000 to 40,000 holes or openings in one imported model. This would take hours to fix in Rhino manually, Also, Rhino 3D Print highlights the Rhino model and shows in color the areas that are bad. Rhino 3D Print decimates the mesh to reduce polygon count while maintaining the original shape. This reduces density while maintaining data integrity. Rhino 3D Print offers mesh refinement. Uniformly, it remeshes across the entire model. Refined mesh works by using various geometric criteria for print quality. After decimating and refining your mesh model, you can get unsightly ripples in the surface. Rhino 3D Print offers mesh smoothing to eradicate these irregularities that are due to noise. Rhino 3D Print offers offset mesh, both inwards and outwards by a uniform distance. It also offers mesh shelling, which is a feature that gives a solid mesh a shell wall thickness. Rhino 3D Print analyzes meshes and then repairs the problems. You can run checks on edges, on triangles, and on vertices. The problem areas are highlighted in color on the Rhino mesh. To 3D print, you can select a printer. The 3D print also offer export to STL and another feature called fit. With the fit volume, a volume cube will appear inside the Rhino model. Your model can be rotated, moved, and scaled to fit into the cube. The gumball is a really good tool to use to get your model into the volume cube. And this will help you visually conform to the volume limitations of your printer. You will see all of the Rhino 3D print commands in the familiar Rhino 5 panel interface. The panels make it efficient for displaying all of these controls in the Rhino application window. So be looking for these features and more in Uday's demonstration of Rhino 3D print. Let's go ahead and welcome Kyle. Hi, Kyle.
Hello.
Are you ready to show us what you have modeled for the presentation?
Buckle your seatbelts.
Okay, here you go. Presenter role is heading your direction.
Hey everybody, Kyle Houchins from the Outside Digital Art and Design. I am also a support tech for McNeil and happy to be part of this today. So what I want to show you is one of the demo models that we're going to be using for today. And this happens all the time in my design practice. I'll get a call from somebody on a Thursday afternoon, 2:30, 3 o'clock, and they'll say, hey, we've got a marketing meeting at 8 a.m. Friday morning, and we need you to just, quote, slap a model together for us as quickly as possible so that we can have something to, quote, show for the meeting. And that's fine. Panic money spends just as much as non-panic money, so I'm happy to take those kind of jobs. We'll typically take something like this and go back through either a model library or a clip art file or some custom pieces that are built to try and as closely capture the client's art intent as possible. And what typically results is we'll be able to throw something together like this pretty quick. And in this model, start to finish was about, I don't know, 4.5 hours to build this thing, because we did have a couple of parts like the little nuts and bolts and some of these, you know, rail pieces and things like that. We were able to pull out of a model library and pull this thing together pretty quick. So job done, right? I take this thing, I put it together, I send it to the client, we throw a couple of renderings together, maybe we, you know, do a couple of screen captures or something like that, or I send them a 3D PDF and they look at it in their meeting. And everybody's happy. Well, the typical problem that comes up is about 3 o'clock on a Friday, they call me back and they say, this is great, everybody loved it, maybe we want to change a thing or two here, but can you just, quote, throw us the model so that we can print it? That's where the problem comes in. So the problem is, since this model was put together very, very quickly with the intent, with the stated intent of just being something to show in a meeting, there's some significant limitations of taking something like this and trying to print it. The first one that you can see right off the bat is something that's developed for a presentation is significantly different than how you would develop it to be printed. And in this case, in order to have something for a presentation that you're going to assign colors to, it's all built up in separate pieces, right? So we've got separate pieces. We've got separate pieces for these, separate pieces for these. This is a piece. This is just a chunk thrown in there and overlapping. This is just a chunk thrown in and overlapping. There's a little doodad in here that I probably grabbed out of a clip art file. Some bits and pieces that are thrown together. Everything's overlapping. Nothing's trimmed. Nothing's shelled. And there's all sorts of stuff in here that would make this a problem to print. Not to mention the fact that if we go through and audit this using some of the built-in Rhino tools like Select Open Polysurface, you'll notice that there's some pieces that they're not even closed volumes, right? It's just stuff that I took, I threw together in space, and if you show the naked edges, you'll see that this is an open volume. You'll notice that there's a surface missing back here because I was going so fast I didn't pay attention to mirror that over. There's a naked edge in here. There's a naked edge in here. There's a surface missing. And I could go through and spend the time to fill that stuff and to take care of it. But the problem is, right, the client has already paid me for this model, and they're now changing their expectation a little bit and wanting this thing to be printed, but they're not always so interested in spending the extra money to get that done. So then I have to have a little bit of an awkward conversation with, hey, this model was just thrown together, and it was really never intended to be printed, and it kind of makes me look like I don't know what I'm doing, right? And some clients are understanding, and they say, okay, fine, we'll pay a little bit extra to fix that. But a lot of clients kind of scratch their head, and there's this awkward silence where they look at me and they're kind of like, what do you mean the model can't be printed? What's wrong with it? Is it a, quote, bad model? Well, it's not a bad model because it served the purpose that they asked me to serve, but in a lot of cases, especially when I'm dealing with marketing groups or folks that don't have a development background, they don't necessarily understand the difference between a presentation model and a production model. So this is where MecSoft and 3D Print comes in, because they're able to take what I'm going to refer to in client vernacular as a, quote, trash model, right? This is not useful for printing as it sits because it's open. And they're going to take this and very quickly show you how you can take a model like this that is currently not set up to be printed and very quickly convert this into something that could be printed. And in my practice, this is something that's very useful because from my point of view, if I can't extract any more studio dollars out of the project by saying, okay, well, now you got to pay me to prep the thing to print, I can very quickly run this model through the MecSoft product and end up with something that is actually suitable for printing. So with that, let me go ahead and hand it over to MecSoft, and they will take this model and show you how to take trash and turn it into treasure.
Kyle, thanks for putting together the great model. And folks, this is Uday at MecSoft. Today we'll take a look at the Rhino3DPRINT plugin, which integrates into Rhinoceros to see how we can address some of the concerns in design and modeling that Kyle expressed today. So first, I'm going to go ahead and load the Rhino3DPRINT plugin. You will notice that once Rhino3DPRINT is installed and you bring up Rhinoceros, you can click on the Rhino3DPRINT 2015 drop-down menu and select Browser. Rhino3DPRINT uses a browser-driven interface, and by default, the browser appears over on the left panel, and it's docked in Rhinoceros. The browser has 5 main tabs. We have Create, Model, Inspect and Modify, Repair, and 3D Print. So the Create tab offers primitive mesh modeling tools. We could create mesh from point clouds and also convert solids and surfaces to meshes. The Model tab provides you with robust mesh Boolean tools, offers mesh offsetting, splitting, which can be used for shelling applications, offset and split, mesh hulling, and also slicing. The Inspect and Modify tab provides you analysis tools for curvature and reflection lines, also provides you with mesh reduction, remeshing, and mesh smoothing tools. The Repair tab provides you with powerful tools for mesh repairs like AutoFix, which can automatically fix for holes, self-intersections, and incorrectly oriented triangles, Stitch and Close to stitch and close open meshes, Diagnose to identify open edges, problems with the mesh geometry, and graphically visualize those, and also to separate and fix and flip orientations. Finally, the 3D Print tab allows you to select the printer, fit the model to the printer's volume, check if the model is ready for 3D printing, and export it to your 3D printer. If you're running this on a Windows 8.1 operating system, you'll also see an additional Print tab in here, and selecting the Print button will automatically call up your 3D print drivers. And you can hit Print like you just print a document out to your printer. Now let's go back and see how we can work with this model so it's ready for 3D printing. First, I'm going to go ahead and convert this to a mesh. So I'll go ahead and use the Mesh from NURBS object tools. We'll select all of these surfaces and poly surfaces, and I'm just going to go with the polygon mesh options with the simple controls, and we'll click OK to create a mesh. And you'll notice that as the meshes are created, they're automatically displayed in the Rhino3DPRINT browser's data tree. The data tree, the browser has 2 sections. The lower half of the section gives you information on the meshes. It shows basically we have a total of 28 meshes with close to 200,000 triangles. Now I'm going to select all of these meshes from the data tree. I'll move it up to a new layer and hide them. So in this model, we also have some moving parts. I'm going to first hide those moving parts so those can be printed out separately, and then we'll just go back and convert these to a mesh. And once the meshes are created, I will go ahead and move them over to a new layer and hide the poly surface geometry. So I'm going to change object layer in Rhino and hide the original geometry. So there's our mesh, and you can see there's about a total of 26 meshes and close to 165,000 triangles. Now let's go ahead and analyze the mesh. We'll do a diagnose from the Repair tab, and I'm going to select all of these meshes. And what I'm looking for here is to check for open edges, or also known as naked edges in Rhinoceros, and you'll see that there are close to about 200 naked edges. So let's go ahead and fix these. So we will use the AutoFix feature and select the entire model. So the AutoFix will automatically look for these open edges and close the holes and any self-intersections. Now when I go back and run the diagnose on the same set of meshes, you will find that there are no open edges, which is great. So there's no issues detected. You'll see that there's a total of 26 closed meshes. Now before we can print these, we need to make sure they're basically combined or merged into one closed mesh. So we'll use the tools under the Model tab, and we'll perform Boolean Unite by just selecting all of these mesh geometries. And now the Boolean Unite process is performed, and you'll see that there's a total of one mesh which has close to 180,000 triangles. Now let's go back and perform a diagnose on this mesh. and you'll see that there aren't any issues detected on the model as well. So when you select the mesh and perform run checks, it gives you a confirmation that there aren't any open edges. Now, sometimes you would probably have to insert like battery packs or other features into the model. That's when Kyle pointed out that you may have to do a shelling of this model. So in order to do a shelling, the first step would be to create an offset of the mesh geometry. So we'll use the mesh offset tool and select the mesh. And in the offset parameters, I'm going to specify an offset distance and the tolerance. I'm specifying a negative value for the offset distance will offset the mesh inwards, whereas specifying a positive value will offset the mesh towards the outside. You will now notice that there are two meshes in the tree, the first one being the original mesh, and as I toggle the mesh entry in the data tree, you'll see the offset mesh as well. As you can see, the offset mesh is such a powerful tool which basically was able to offset such a complex geometry in here. Now let's go ahead and analyze this offset mesh in Rhino by creating a section view. So I'm going to go up to the front view in here, and I'll create a clipping plane. We'll insert a clipping plane in Rhino. And let's go over to the perspective view. And I'm going to go ahead and hide the mesh wires in here so it's easy to view the model. And let's enable the clipping plane by selecting the clipping plane right there. Now there's your offset mesh, and you can see the two meshes as you view the model. So you can see that all the different meshes, individual meshes were united, and then it performed a complex offset of the mesh geometry. You can also move the clipping plane around to view it parallel to the active clipping plane that you're at. Let's go back and disable the clipping plane, and I'm going to go back to the front view and do the same process to disable the clipping plane, and we'll hide it. Now, in order to go back and shell this model, I would need to split it. So we'll use the split tools from the model tab, select the two meshes, and press enter. Now the splitting occurs in view parallel to the C plane, the construction plane, and you have two options in the splitting where you can either cap the results or not have it capped. Now selecting cap will automatically fill the gap between the offset mesh and the original mesh, and you can also pick the splitting plane location. You can either graphically pick it or use a slider control in here. Now I'm going to have it split right at the center line, so by default it picks at the midpoint of the model. I'm going to click the split button, and the split is in progress. Now while we wait for the split process to be complete, let's go ahead and take a look at some of the other powerful features that are offered in Rhino 3D prints. So we'll go ahead and bring in a model here which shows some issues with the mesh. As you can see in the wireframe mode here, the inside of this mesh shows self-intersections. I'm going to switch the view over to the ghosted view, and as you can see, the interior of this mesh has self-intersections on it in several places. Now to fix this manually would involve a lot of time, so let's go ahead and run the AutoFix under the Repair tab. So we'll pick AutoFix, select the mesh, and you will notice that the AutoFix automatically fixes the self-intersection in just a few seconds. So you can see how powerful these tools are that are offered in Rhino 3D Print, which will help you get the model prepared and ready for 3D printing. Now let's go back and check if our split process has been completed, and looks like it has. Great. So let's go back and analyze this model in here. So let's go to visibility. I'm just going to go ahead and hide the rest of the objects, and we'll take a look at the mesh we just split right there. Now I would like to ask Kyle if this is what you are looking for when you talk about shelling and offsetting.
Can't talk, I'm dancing. That's fantastic. That's exactly There's about a million times that I need that exact capability to be able to take a junky thrown together model, shell it, and throw it through a printer. That if I would have had this tool 10 years ago when I was just getting started out, I would have been unstoppable. This is fantastic.
Great, Kyle. Thanks for your input on that. So now let's see how we'll go ahead and, make this model ready for 3D printing. So we'll go up to the 3D Print tab, and you can go ahead and select a printer from the list of available printers, and you can add additional printers also to the list. You can also click on Toggle Printer Volume to display a printer's volume. And let's go ahead and first use some of the orientation tools in Rhino so that the model is oriented correctly for printing. So I'm going to go back to the 4-view layout, and let's use the gumball to rotate this part around. So I'm going to rotate it by 90 degrees from a couple of views. So the model will be ready to be placed inside the printer's volume. So to be able to place it in the printer's volume, we could use the fit meshes and just grab the mesh and use from the available options in here. You can align it to the bottom, which is the floor of the printer, in the Z, and also you can do center if you like in X and Y, and select fit. So this automatically fits the model into your printer's volume. In the next step, we could go ahead and perform a check to make sure that the model is ready for printing. So we'll go ahead and perform a check on it. And this is going to check for if the model is closed and watertight, if the entire mesh is completely inside the printer's volume. And also it checks for wall thickness based on the specified values, and also for overhangs. Now once you are satisfied with these results, you can go ahead and select the export button to print this out. So you can save it as STL, SLA, or AMF. Now if you're running Windows 8.1, you'll also have a print button which automatically displays the printer settings and options in the Rhino3DPRINT browser interface, and selecting print will be able to also print out to your 3D printer. So this would be a typical workflow of how you'd be able to take a design model and work with it to make it ready for printing. Now let's take a look at a couple of other examples here where we can create mesh from a point data. So I'm going to go ahead and import a scan data in here. So I'm going to grab this footrest model. Now this is basically in a scan format, and the data is separated by a space, which are the options for delimiter, and we'll click open. So this basically imports a point data, and as the file was imported, you'll see that the data tree in Rhino3DPRINT displays the point cloud data and shows it has close to 500,000 points on it. Now, the point data cannot be sent directly to a 3D printer, so we need to convert it to a mesh, and then we should be able to fix the mesh and print it out. So let's take a look at the workflow here. So in the Create tab, we'll click on From Point Cloud. So we want to create a mesh from the point cloud. We'll select the point data, and you'll notice that the point options mesh from are displayed in here. You can specify these options and then select Create. Now this basically creates a mesh from the point data using all of the mesh creation options and parameters we put in. And you'll notice that for a point data which is close to 500,000 points, the process of creating the mesh is fairly fast and quick, and you'll notice that we have a mesh which is now close to 950,000 triangles on it. Now let's hide the point data so we can visualize the mesh more clearly. So I'm going to go to the shaded view, and also turn off the display of the mesh wires so you can view the model. It's more visible, better to view the model. You can see that the model was well created, but you can see there are several holes on this model, so which cannot be directly sent to your printer. So if you go up to the Repair tab and perform a diagnose on it, now this will be able to check and show all the open edges. You can see that this model contains over 38,000 open edges. So fixing this manually will probably involve hours and hours of time. So let's go ahead and perform an auto fix. So we'll use the auto fix, select the mesh geometry, and then press enter. So this automatically looks for holes, self-intersections, and any incorrectly oriented triangles, and automatically fixes the mesh. So you can see that there's over 38,000 triangles, and it's working on it. Now, while we wait for this process to complete, let's go back and take a look at some of the other features for mesh repair that's available to you in Rhino3DPRINT. So I'm going to go ahead and grab this car model, and we'll go ahead and turn off the display of the mesh wires. Now you'll see that this model may have been created from a legacy program or legacy system. So that's the reason why you're probably seeing there are several open meshes on this model here. And I'm going to run a diagnose on this model to check for open areas and issues on the model. So you'll notice that there's close to about 26,000 plus open edges, and you'll also notice that the bottom of this model is not closed. So to be able to make it ready for 3D printing, we can use a powerful feature under the repair tab called stitch and close. So I'm going to run stitch and close, and it's going to stitch all of these 300 plus open meshes into a closed mesh which is ready for 3D printing. So the stitch and close stitches open edges and also fills any gaps in the model to create a closed mesh. You will now notice that there's just one mesh which results in a little over 150,000 triangles, and notice the bottom is closed, nice and clean. And if you run a diagnose on it again, you will find that there aren't any open edges, so the model is now ready for 3D printing. I would also like to show you one other example in here where you can see how powerful the stitch and close tools are. So I'm going to go ahead and import this DXF file which has 3D meshes. I'm going to use the default import options in here. And there is a mesh where you can see that there's two meshes. If you take a look at the mesh, you can see how bad the meshes are. So this is probably from a reverse engineered process where you can see this meshes have a lot of issues on the triangles on the model here. Now we can perform a fix very quickly using the stitch and close function. So we'll just go grab this model in here and press enter. And in just a fraction of a second, the model is fixed and ready for 3D printing. Now let's go back and take a look at if the auto fix was complete, and looks like it is. There you go. You can see that there's close to about 977 plus thousand triangles on this mesh geometry. And let's run a diagnose on it to check if there are any open edges. And you can see that there were no issues detected. So great, the model is now ready for printing. Now, one of the powerful tools that's offered in the 3D printing is known as reduce mesh. So this can reduce the triangle count on the mesh either by a percentage or by a maximum deviation. So since this model has close to 1 million triangles, I'm going to use by percent, and I'll set the percent to 70%. So selecting reduce will reduce the mesh to the specified triangle count, and it also tries to maintain it close to the original geometry. You could also use the reduce mesh by a maximum deviation if you want to keep it more closer to the actual geometry. And you'll notice that the reduce mesh process was so fast and also reduced it accurately down to close to 300,000 triangles on it. Now let's go ahead and display the mesh wires on this model, and you'll notice that the meshes are not very uniform, so it might not be very easy for the printer. So what you could do is use the uniform remeshing that's offered under the Inspect and Modify tab in Rhino3DPRINT. Now this provides different remeshing parameter options, and in this particular example I'm going to demonstrate how we can do a uniform remesh, and I'll specify an edge length of 50 thousandths, and we'll set the iterations to 2. So in this process, it's going to remesh the meshes and create triangles of the specified edge length. So it creates uniform triangles on the geometry, and look at it, how nice the remeshing process is, and look at the triangles, how uniform they are. And it's quite fast. Now you can also notice that there are some areas where you may want to smoothen these out, so you can perform the smooth mesh feature, select the mesh, and go ahead and specify your vertex shift directions for smoothing. So I'm going to use both directions and set the number of iterations to 3, and this will basically smoothen out those sharp edges. Now the smooth mesh and remesh tools are very effective tools which can help you make the printing process a lot easier and improve the results of your 3D printing. Now let's go ahead and fit this model to the printer's volume. So we'll go ahead and go up to the 3D print tab. We'll basically select the fit and select the model, and we'll specify it to be fit to the bottom and the center, and click on fit. So this basically fits the model to your printer's volume. If you go ahead and perform a check on it rather than visually inspecting the model, it will tell you if the meshes are completely enclosed inside the printer volume, which it is. And also it can show you whether the mesh is closed, and also determine if there are any thin walls and overhangs based on the values that were put in, and you can see their overhangs are also being marked in and shaded on the model. So once you're satisfied with the result, you can go ahead and select export to export out to your 3D printer. You can export in STL, SLA, or AMF if you're running Windows 7 or any other earlier versions of Windows operating system. If you are running Windows 8.1, you'll have a print button. I'm just going to bring up our help documentation here to show where you can find the print button, and you will see that it automatically displays your print driver interface, and selecting print will be able to print it out to your 3D printer. So I would now like to go ahead and pass this on over to Anita Anand, VP of Sales, who will be able to give you more information about the 3D print product.
Thank you, Uday. Hello, everyone. Hope you got a good feel for the features of our Rhino 3D print product today. I think Uday did a great job with that demo. It was a quick presentation, and you may not have caught every single detail. So what I'd like to do is actually walk you through our website. Now, unfortunately, glitches happen, and without glitches, what fun is life? Just discovered that our website's down, but I'll try to do my best to go through the different tabs we have there, so I can give you a quick rundown on what we have up there for you. Website, MecSoft.com. Once you get there, the second tab up there, the Products tab, will basically pull down a 3D print menu. When you click on that, which is what I won't be able to show you today, you will be sent to a detailed Rhino 3D print page. Now this page, looks like our website's back up. What do you know? This is good news today. If we can scroll down a little bit more. There you go. So we have two tabs there that I'd like to bring your attention to. One is the Resources tab and the Feature List tab. Now, under the Resources tab, you can access the Rhino 3D print data sheet, the feature presentation, quick start guide, as well as some of the training videos we've put together for you. This is a great resource to get you started with your 3D printing process. Now the Feature List tab up there gives you a detailed description of all the features included in the Rhino 3D print product, some of which Uday did have the time to go through, but this will give you a better description of what is included in the product. Now, the most valuable piece of information on that page really is that blue button you see there, the download demo button. This button poke gives you access to a free 30-day trial of the Rhino 3D print software. I know we had several questions coming in where you could see one of our demos, take it for a spin. This is where you'd click and get that demo for you. To be noted that this demo is a 30-day free demo. You have a fully functional product that will help you get your part cleaned up and ready. Save it and send it to that 3D printer you might have. So download the product, take it for a spin. Comments, we'd love to hear. Parts that you cut, we'd love to see. And if you'd like us instead to run a quick demo for you, we do offer free one-on-one online sessions at a convenient time. So call us, write to us, and we will make that happen as well. Now I know most of you are thinking, okay, what is all this going to cost me? Well, we do have our pricing on our website as well. Up there on the sales tab, we've sectioned it into the North America and international pricing. Let me go through the North America first. Taking a little bit of time here. But let me go on. We do have it sectioned under the Rhino 3D print option. We have the pricing there. It is a $999 product, as you can see, pretty reasonably priced. There you go. And for a short time, for however, a couple of weeks until the mid-February date, 15th, we are offering our early adopters a 25% discount. So it brings the price down to $749. This is a good time to get those 3D printers fired up, folks. Now for our international viewers, do contact our sales office here, sales@mecsoft.com. We will gladly direct you to a reseller in your area. This will help you not only get the product, but also obtain complete support for the Rhino 3D print product as well. Now, once you get that product in-house, you can always call us, write to us. Our support team will definitely step you through any issues you might have. We do help. We also offer online training sessions. We offer classroom training here at MecSoft in sunny California. We'd love to see you here. And at this point, this about sums up what I'd like to share with you today. I'm available later for questions that you might have. But for now, I'll let Mary take us into the next section of this webinar. Mary, take it away.
Great. Thanks, Anita. We have a lot of really good questions that I want to propose to Joe and Uday and maybe to you also, Anita and Kyle. So you can jump in and we'll just take turns answering these for a couple reasons. They've come in very quickly, so it's even been hard for us to keep up with them. So I'd really like them answered for the video so those who are not attending live today can benefit by getting these answers. So I'm going to start with the first question, and that is, why do I need Rhino 3D print? Joe, Uday, do you want to sum that up for us?
I can sum that up.
Mary, I can take that question.
Okay, you and Kyle fight over it.
Go ahead.
Okay.
Okay.
I was going to say I can sum it up from a designer's perspective in the fact that the current mesh processing tools that are within Rhino would not allow you to do any of the stuff that you saw here today. On my desk at my disposal, I have Freeform, I have ZBrush, I have Rhino, I have SolidWorks, I have a very old dusty copy of Alias, and out of all of those products, with the exception of some convolution between Freeform and ZBrush, being able to do this level of mesh manipulation, to be able to take something, a model of this complexity, mesh it, unify it, shell it, and have it be something that you could print with a couple of button clicks is just not currently possible within Rhino. So anybody who's tried to use the mesh Boolean tools in Rhino, and this is no secret to anybody within McNeil, the mesh Boolean tools within Rhino are, shall we say, limited. and
Good word,
so
Kyle.
the capability that MecSoft has added here, the capability, I was going to say horrible, but I think limited is the better way of
Thank
saying
you.
it.
Thank you for that.
So the capability that MecSoft has added here with the mesh processing tools is really something that you don't have currently. So it's solving a problem that a lot of people have that isn't being addressed with the current with the tools as they currently sit. So from my perspective, this allows me to take something, model it very, very quickly, slap a model together, mesh the thing, unify it, and shell it, and really maximize the amount of money. I just bought a 3D printer myself, so I'm very excited about this, in the fact that having this plugin gives me the capability to model in NURBS, I don't want to say sloppy, but let's say less carefully, meaning that I can also go faster. So my studio time gets billed out hourly, so the faster I go, the more money I make, and so the ability to be able to model something very, very quickly, unify it, and then shell it, and then print it, and hand over my client something that they can then put electronics and batteries and motors and all that kind of stuff in, is something that's really, really attractive from my perspective. So.
Great, that's really helpful.
Maybe I interrupted you, so now you can give him the official answer.
Well, no, it's not. It was actually Joe. It's Joe here trying to, fight it over with Kyle. But I'd like to give a more, product-specific viewpoint. The way we at MecSoft see it, we approach this from a, application perspective. So definitely there are some tools in Rhino 3D Print that also Rhino also has. There's some overlap. But what we have tried to do is, take some of these tools and automate it in Rhino 3D Print. So, the first class of tools that we have is an automation of some of these tools that are specific to 3D printing. If you're sitting there and you're thinking about actually 3D printing, you would like some of these Rhino general purpose tools to be automated. That's one thing we've done in Rhino 3D Print. And then we've also added tools that are very specific to the 3D printer. For instance, like AutoFix, mesh smoothing, mesh refaceting, creating of the slices for debugging purposes, and then maybe the alignment and the fit of the mesh geometry to the printer volume, ability to load multiple printers, checking for mesh overhangs, and then checking for the printer volume fitting criteria, things of that nature we've added, which are completely different from the Rhino tools and really are application specific. And also, we are working on more tools. You will see them come out in the future that are very specific to 3D printing. So short answer, yes, there is overlap, but we do have a lot more that are application-specific tools in Rhino 3D Print.
I think back
All right, Mary,
on.
you can take over
Thanks,
now.
Joe. Yeah, I think back on Kyle, the webinar that you did on getting a Rhino model ready for 3D printing, and I've shared that, and I'll also include it in the follow-up email. But for one or maybe less than 10 holes in the mesh, you could probably go through one of the techniques that you covered in that presentation. But like we saw with the footrest, there were 44,000 holes. And that would be, nearly impossible to sit there and fix, at least, I guess, in a reasonable amount of time with just Rhino. And back to one of your other points, Kyle, about designers. I work with sculptors and jewelers. They come to mind the most, who are designers, and they put together their designs in Rhino, and then all of a sudden it looks great on the rendering, but then all of a sudden they need to prototype, and they have, you know, hundreds of naked edges and booleans that won't work. And what's very interesting to me about this product is that a mesh can be generated and then fixed and 3D printed. So it's a different way to get that 3D print out. Instead of trying to fix the NURBS model, you produce a mesh and then fix the mesh, and then you're on your way. So those are just a couple additional comments. So thanks, Kyle and Joe. I wanted to run. My
business partner and I always used to joke about, wouldn't it be great if there was some magical tool that would make your model better, and it would just have one giant button that just says "Make Better." And this is close. This is pretty close to the "Make Better" button.
Right. Well, I have also been asked for, and this goes back to my AutoCAD days, the Make 3D button.
Yeah,
so we have a 2D drawing and make 3D. So,
It should just have one button for the whole software, and it's the "Make It So" button.
Yes, yes. Read my mind button. Exactly. Very good, Kyle. Exactly. Now this
the talent plugin.
That's what we're relying on you for. But anyway. I have some questions here, very good questions, by the way, that were submitted during the presentation. And this one, Joe answered. So I just want to put it out there, Joe, and have you answer it. What are the point-to-mesh limitations? Is there a maximum point count to convert to a mesh? And can you make some comments about the speed of the conversion?
We haven't really stressed the limits of the product yet. I mean, we have tested and we have done some preliminary tests on it, and we've gone up to about a 10 million triangle model, actually a little bit over than that. We're able to bring in, create meshes at 10 to 12 million triangles. That's the limit that we have reached. But obviously, as far as the performance is concerned, it relies heavily on amount of memory, amount of RAM you have, the amount of processing speed that you have under at your disposal. It is a multi-threaded system, so number of processors are important as well. So quite a few factors. But as you saw in the demonstration that Uday just did, it is one of the fastest systems that we have seen out there. In terms of fixing up, but not just the point clouds, but also fix up and reduction and all of the tools that we have. So
great.
I would strongly urge you to download our demo and run your own tests on it rather than take my word for it. And the proof of the pudding isn't actually you running it, and that's why we have that demo out there. So
right, and also let MecSoft know if you run into a model that causes problems, because those are needed to make the product better. So and same with goes for us here at McNeil. We need to know, we need to get those models that aren't working.
Absolutely.
Okay, Joe. Let's see. The next, I think, couple questions here were pretty straightforward, and I think Uday really answered this in his presentation. Can this tool fix models that are not watertight? Yes. Can it create watertight meshes? Yes. Does it auto-flip inverted triangles when fixing? Yes. So those are good to mention. Terry Wellman is in the audience from the Model Makers Association, and he had some really nice comments out there, Joe, about using the demo and how it streamlined their process. So we'll ask for a show of hands, and if any of you have questions, go ahead and raise your hand while we finish up going through the questions that we covered. And hopefully, Terry, if we can get you to say a few words that would be really wonderful. One of the questions, does CNC include 3D printing? And it's actually a different category. So CNC is subtractive manufacturing, 3D printing is additive. A lot of questions about getting the demo. And I'm just scanning here to make sure. Oh, I think one of the other big questions, Joe, was what operating systems are supported. Do you want to go over the system requirements for Rhino 3D Print?
Yeah, we support Windows 7 and Windows 8.1. Actually, the product that Uday was running on Windows 7. We actually have run it even on Windows XP, even though that's not supported Windows. As far as the product resource requirements, we run on whatever Rhino requires. If you have that box, if you have that sort of requirements, you will be able to run our product. But obviously, having said that, it depends on the type of models you're working with. If you're working with large models, you definitely want to increase your RAM as well as your processor speed as well.
And if
actually, if you go to our I'm sorry, Mary. If you go to our website, it does list all of the resource requirements for your product. Unfortunately, I can't go to that page right now, so.
No problem, and we're looking at my screen. But the using the Windows 8.1 3D print drivers would be limited to that version of Windows?
Yes.
Yes.
Yeah,
okay.
So if you're running on a Windows 8.1 box, when you go to the Export tab or the 3D Print tab in the product, you will actually see a print button, and that one will use the Windows 8.1 print drivers, 3D print drivers that come with the operating system.
Okay, perfect. And that's really the most important questions I think that we had. The questions that were submitted here are really helpful to produce an FAQ. So we'll be getting those over to Joe, and maybe he can add some additional information on their website. Alfonso has, great. We have a few hands raised out here, Joe. So let's go ahead and bring Alfonso on. It may be a little bit awkward as we're testing his mic, so just bear with us. Alfonso, do you have a question for us?
Yeah, just one really quick question is something that could be really useful for to print from Rhino is to generate the supports for overhangs. So I don't know if right now the software is ready to do something like that, or if we can expect something in the near future, because this tool is something that is really important for us.
All right, Alfonso, thank you very much for your question. That's automatic support generation as well as manual support generation. That's a very key requirement. A lot of people are asking us. And as you know, this is a very young product. We've just released it. And that's number one requirement for the upcoming release. So we are working on it. That's something that you'll expect to see something in 2015 pretty soon come out with the product.
But Joe, as far as manual support generation, I remember Uday showing an analysis where there's possible problems where support generation would need to be created. Is that in there? Okay.
Yeah, there's an overhang detection algorithm in the product where you can color code. When you detect overhangs, it'll color code the model. And Uday, if you want to quickly bring up the product, we can show that. And then you can use the Rhino tools to actually create supports right now. But that's a manual process. So we are looking at automating that.
Okay, the screen is heading back
Sorry,
to
Joe, did you ask me
Uday.
something?
All right.
Uday, could you show the analysis for support generation? I'm sending presenter back to you.
Sure, will do.
The
Great.
overhangs, yeah.
So if you go over to the Repair tab, select and run a diagnose. Sorry, if you go to the 3D Print tab and you do a check mesh, this will basically analyze for overhangs, greater than the specified value, and you can look for these overhangs in these areas, and you can.
Yeah, so once, this is the very manual process, as you can see right now, this detection, so you will have to actually manually go ahead and create the supports using Rhino's tools, and then use our Boolean tools or Rhino's Booleans to actually Boolean the supports into the model. We are working on automating that, so stay tuned.
Perfect. Thanks, Joe and Uday. Terry Wellman, can we unmute your mic? Hey, Terry.
Hey, can you hear me?
We can hear you great. Thanks for joining us today.
No problem. I want to say something about MecSoft. We have a number of their products, and I've seen questions on the comment list about people asking about support and such like that. And this also goes to McNeil as well. The support from both of these companies as far as technical support goes, it's first class. And I'm not trying to buy points here. It's just when we find ourselves in a bind, the first call, depending on which program we're using, whether it's RhinoCam Pro or Rhino or RhinoArt, whatever, we call their tech support lines or chat lines, and it's awesome. We get answers right off the bat. And we can also send files in and work a file through a demo real quick and figure out what our problems are and get back to making money.
And Terry, you're still involved with the Model Makers Association.
Yeah, I'm a past president of the Association of Professional Model Makers, and Charles Overy, who is another past president, was on the listening in on the webinar. In fact, he has a bunch of questions we've been throwing back and forth about this. So and Charles also has materializes magics. So there's some comparisons going on, and I would assume there's probably a few other members that were on the webinar today too. So it's yeah, if you're a professional model maker, check out modelmakers.org.
Great, Terry. And you're using
Thanks,
the
Terry,
demo.
for all your kind words.
Can you just clarify, Terry, are you using the demo right now?
I am, and I'm about to call Anita and buy the product.
Well, that's a great endorsement. Thanks, Terry, for saying hi and for getting your model makers to join us today. I'm sure you had a little bit of influence. Let's see. Let's come down to Mitch. Mitch has his hand up. Mitch Heineck from Switzerland. Mitch. Hi there, Mitch. We'll see if Mitch can.
Hang on, can you hear me?
Yes, very well, very well.
Yeah, so I decided to watch this on my iPad. So it works great. So hi, everybody. Hi, Terry. I'm also a member of the APMM, model maker here, and I have just a couple of questions from an educational standpoint since I work in a school model shop. And this looks just fabulous. I mean, this looks like it's got tools that are in a lot of ways better than Magix, which we have, which is just like mega expensive software. So I'd like to be able to get rid of that, and then on top of that, pretty much all of our 3D models that go to our printers run through Rhino anyway. So it'd be just great to have this inside Rhino. So that's just really excellent. I'm really excited. Great presentation, Uday. Question, obviously, is on educational pricing, because you only mentioned the sort of commercial pricing, Anita. So I'm just curious, what's this going to cost to school?
Hi, Mitch.
Hi there.
Now we have different. How are you? I'm doing well, thank you. Having a great day here with all our viewers. Well, we are starting out at 5-user network level at $750 for the EP market. We have, higher number of user costs for those too, so I can put that out. I can send you an email. I'll put that out on our website too, if needed. But yeah, we have great pricing for schools, like we've done with our RhinoCam product too. So yes, absolutely, schools are important to us.
Great. So that's really excellent. And I'm assuming that this is also a hardware key product like the milling software, which of course we also use in our school and everybody loves.
Yes, it is. Yes, it is. And it can, if your school already has a hardware key, all you need to do is license the product onto that same hardware key. So.
Okay. Well, I expect you'll probably have an order. You'll probably have an order from us pretty soon.
Nice.
And thanks again for the great product, and thanks for the demo.
Yeah, thanks, Mitch, for the comparison. Yeah, thanks for the comparison to Magix and your the other software that you're using. Any other questions, Mitch, for Joe or Uday?
Nope, that's it. Just greetings to everybody from snowy Switzerland. Well,
great to hear from you, Mitch. Have a good day. Maybe you'll stick with us for the rest of the presentation. Gustavo, you have your hand up. Let's go ahead and bring you on. Hi, Gustavo. If you're talking, Gustavo, we can't quite hear you yet. Sometimes the hands get raised by mistake, so we don't want to harass you too much. I'm just scanning through the list here, Joe, and it looks like we have come to the end of the questions. Do you have any closing comments, Uday, or Joe, or Kyle, or Anita? I think we'll go ahead and move into the end. Yes.
Yeah, the only thing I would say is we're very sorry that our site is down right now, so please check back later. We're working very feverishly right now trying to get the site back up. So it should be back up in an hour or so, so please check back later for additional information on our product. Well, thank you very much for attending.
Well, I'm happy your internet didn't go down, Joe. Sorry about your site problems, but it always seems to happen that way. Kyle, any closing remarks?
There was a couple of questions about G-code, and I may have been typing and they missed it. What, as far as G-code generation for printers that use, it looks like there was a couple of questions in there about specific printers that use G-code specifically as opposed to printing off of an STL file. Is there any capability within there for G-code?
This is something we're working on. Kyle, what we wanted to do is, I mean, obviously we do a lot of G-code processing. That's really up our alley. So one of the things that we are looking at is to have a 3D print module that's part of our CAM module that would basically take a mesh model and create the slices automatically, given the user parameters, and then outputting G-code to whatever machine that you have. Cool. That's not ready yet, but that's something we're definitely looking at. So it'll be out sometime this year.
Okay. Awesome. Well, here is our final screen, and there's some helpful links out here. We'll keep this active for about 5 minutes or so after we close down the webinar. Thanks to our outstanding presenters and support staff. We really enjoyed seeing you and working with the Rhino 3D Print. And thanks to all of you for joining us today. Again, you'll be getting a follow-up email here with the links to the video. And we hope you have a good rest of your day, and we hope to see you in a future webinar. Bye now.